In problems in moments. So this is the next problem. The first four moments about a point 4 are given and you need to find out the first four center moments. As I discussed in the previous problems, again I am repeating, moments are of two types. Okay, central moments and non-central moments. And generally in numerical problems you will be given with non-central moments and you need to calculate the central moments. So here the first four moments about a point are given. Central means about x bar, non-central means about a. We indicate central moments with mu r and non-central with mu r dash. And mu2 always mu1, these are nothing but the first four. Try to write the relationship between central and non-central. Mu1 is 0, mu2 is nothing but mu2 dash minus mu1 dash square, mu3 is nothing but mu3 dash minus 3 mu2 dash mu1 dash plus 2 mu1 dash cube. This is mu4 is nothing but 1 3 2 1 4 6 3. Mu4 dash coefficients 1 mu4 dash mu2 dash. So I think we know these are the relationship between central and non-central. If you read the question, the first four moments about a point are nothing but non-central moments. So whatever the point, you should take that as A. Here A is 4. The first four non-central we write with dash, means first four means first value indicates mu1 dash, second value mu2 dash, third value mu3 dash, mu4 dash 108. The first four non-central moments are given. You need to calculate the central moments. So mu2 is nothing but mu2 dash minus mu1 dash square. What is mu2 here? 17 minus what is mu1? Minus 1.5 square. So this is 17 minus 2.25. This is 2.25. Okay, which is nothing but 14.75. You should calculate mu3, which is nothing but mu3 dash minus 3 mu2 dash mu1 dash plus 2 mu1 dash cube. What is mu3 dash here? Minus 30 plus minus 3 mu2 dash is nothing but 17. mu1 dash is, again I am substituting all the corresponding values in place of mu1 and mu2 dash. So I think you can simplify this. You will get this as 39.5. This is mu3. So what is mu4? mu4 dash 1463 are the coefficient. More 4 mu3 dash mu1 dash plus 6 mu2 dash mu1 dash square minus 3 mu1 dash cube. So again if you substitute mu4 here, that is 108 minus mu3 is minus 30 plus mu2 is 17. This is power 4 minus 1.54. On simplification you will get this as 142.3125. So far we have discussed three problems where three are of the similar model, where first four non-central moments will be given to you. You need to calculate the first four central moments. Let us discuss one more problem. The first three moments about origin are 3, these are the moments given to you. The question here is calculate mean comma variance. So what are given here? The first three, the first four are given. The first four non-central moments about origin or about any point always stands for non-central moments. So mu1 dash is 3 here. Okay. Mu2 dash is, as the non-central moments we write with dash. Mu3 dash is 91.6. Mu4 dash is 796 point. These are given to you. Okay. About origin means A is nothing but 0. About origin means A value 0. What you need to calculate? Mean. You need to calculate mean comma variance. So you know that mu1 dash is nothing but x bar minus A. So I think x bar is nothing but mean here. So x bar is equal to mu1 dash plus A. So what is mu1 dash? 3 plus A is nothing but, as origin is 0, x bar is nothing but 3. Next one is you need to calculate variance. What is variance? Mu2 is called variance. What is its formula? Mu2 dash minus mu1 dash square. 20.6 minus 3 square. 20.6 minus 9, which is nothing but 11.6. So variance is nothing but 11.6. So these are the two models, and also we have few more problems on this. After discussing skewness and kurtosis, we are going to do the problems of another category. Okay, so let us discuss a new topic here. So that is nothing but, if you look into your syllabus, you will find another topic called skewness and kurtosis. So these are nothing but you will have small theorems on that. I think this is a quite new word to you. Skewness. When do you call a given distribution is skewed? Means, first of all you should know what is a symmetric distribution. So it should satisfy three conditions. When do you call a distribution as symmetric? Means when mean is equal to, median is equal to mode. Whenever for a given data or for given distribution, after calculating mean, median, mode, if mean is equal to, median is equal to mode, and also if, I think we have three quartiles in general, Q1, Q2, Q3. If at all Q2 minus Q1 is equal to Q3 minus Q2, means if this is the middle value of these two. Okay, again I am repeating. First condition is mean, median, mode should be equal. The second condition is nothing but, depending upon the quartiles, there will be three quartiles called Q1, Q2, Q3. If at all the second quartile is equidistant from Q1 and Q3, that is Q2 minus Q1 is equal to Q3 minus Q2. If Q2 is equidistant, means the distance between these two should be same as these two, that is Q2 minus Q1 is equal to Q3 minus Q1 is satisfied. And also after plotting the data on the graph, bivariate graph, if you observe, the distribution is nothing, the curve of the so plotted data shows a bell-shaped curve. Okay, if it is bell-shaped one, we call if these three conditions are satisfied for any distribution or given data, we call the given distribution as symmetric distribution. To discuss about skewness and kurtosis, first of all you should discuss about symmetry. When do you call a given data as symmetric distribution? If at all the three given below conditions are satisfied, we say that the given distribution is nothing but symmetric, that is mean is equal to, median is equal to mode, and Q2 is equidistant from Q1 and Q3, that is among Q1, Q2, Q3. If at all Q2 minus Q1 is equal to Q3 minus Q2, and after plotting the data on the bivariate graph, if it shows a bell-shaped curve, we call the given distribution as symmetric. So what is skewness? Skewness is nothing but lack of symmetry is called symmetric. Skewness means whenever a given distribution in general can be either symmetric or skewed. Means if the distribution given is not symmetric, we call the distribution as skewed. That is, the distribution can either be symmetric or skewed distribution. If at all, when do we call a distribution as symmetric? The three conditions. What are the three conditions? Just now we have discussed. Mean should be equal to, median should be equal to mode. Okay, this is the first one. Second one is nothing but Q2 minus Q1 is equal to Q3 minus Q2. That is, Q2 should be equidistant from Q1 comma Q3, and the distribution should be a bell shaped. If at all these three are satisfied, we call the distribution as symmetric distribution. Okay, if all the conditions are not satisfied, that is mean not equal to median not equal to mode, and Q2 minus Q1 not equal to Q3 minus Q2, and the distribution is not at all bell shaped. Means if all these conditions are satisfied, we call the distribution as symmetric. If those are not satisfied, we call that as a skewed distribution. Okay, let us discuss about the types of skewness in the next class. Okay, thank you.